Welcome to the AI Research Roundup. I'm Alex. Today we are looking at a paper from the Hugging Face trending list, published on September 8, 2025, just yesterday. The headline is that it delivers a modern multilingual encoder that beats previous multilingual encoders on classification and retrieval, and even rivals much larger decoder systems on low-resource languages. The paper is titled mmBERT, a modern multilingual encoder with Annealed Language Learning. And, as we will see later, the implications for model training are quite significant. In short, it scales to 1,833 languages, uses an annealed language schedule, and shows big gains without massive compute. On X, researchers highlight that the new multilingual encoder replaces XLMR's 6-year reign, runs 2 to 4 times faster, and even beats O3 and Gemini 2.5 Pro with open models and data. Engagement looks solid, with roughly 180 total likes across posts. Alright, the previous figure set the training recipe, and Table 1 details the data mix across stages. The table shows token budgets and percentages for pre-training, mid-training, and the decay phase, which total about 2.3 trillion, 600 billion, and 100 billion tokens respectively. Higher quality sources like Domino and FineWeb 2 dominate mid-training, while the decay phase shifts to compact cleaner sets such as Wikipedia and textbooks. This split matters because the late stage focuses learning on curated data, while language sampling becomes more uniform, accelerating gains for low-resource languages. So the previous figure summarized token sources by stage. Figure 1 shows how the language sampling became flatter across training because the temperature moved from 0.7 to 0.5 to 0.3. The top panel shows a strong high-resource bias in pre-training. The middle panel reduces that bias in mid-training, which opens space for mid-resource languages. The bottom panel is the decay phase, where the distribution approaches uniform, so newly added languages learn quickly without oversampling scarce data. So, the previous figure showed the sampling shift across stages. Table 3 reports extreme scores, which span cross-lingual understanding, question answering, and structured prediction. mmBERT base leads with a 72.8 average, topping XLMR base at 70.4 because it jumps on XNLI, PAWSX, and TidyQA. The small model also wins its tier, with gains on XCOPA and XQUAD. Structured prediction lags slightly, likely tied to tokenization quirks, but the classification and Q&A margins are clear. Okay, the previous figure highlighted multilingual gains, and Table 2 reports English, GLUE. The table shows that mmBERT small averages 84.7, clearly ahead of multilingual mini LM at 78.3. The base tier averages tell the same story. mmBERT base reaches 86.3, approaching modern BERT base at 87.4. Strong columns include SST-2, QQP, and QNLI, which indicates balanced single sentence, paraphrase, and inference strength. Alright, the previous table covered English GLUE. Figure 2 shows how adding 1,833 languages in the decay phase lifts low-resource performance. The TQAD panels report F1 jumps, with the base model rising from about 17 to nearly 30, which signals fast learning despite late exposure. The FOQA panels show even larger gains, climbing from roughly 59 to 76 for base. The merged checkpoints retain most of the boost, while balancing with English-focused variants. Okay, 2 takeaways stand out. The annealed language schedule with inverse mask rates unlocks rapid gains for over 1,700 low-resource languages, and a modern encoder delivers state-of-the-art accuracy with 2 to 4 times faster throughput. The broader implication is simple. Smart curricula can beat brute force scaling. That is it for the AI Research Roundup. I am Alex, thanks for listening.